use note 86. Note 86. Okay, first step, we're going to look for symmetry, so let's find f of negative x. F of negative x is equal to negative x to the third minus 40 times negative x to the second. The odd power changes signs, negative x cubed. The even one does not. So that's the same as a negative pulled out, x cubed plus 40x squared. And that is not equal to f of x, and it's not equal to f of negative x, or negative f of x. Thus, no symmetry. Okay, we didn't get anything out of that. Let's go to step 2. We're going to find the real zeros, and to do that, we are going to try to factor to find those roots. Let's see, I think we can factor. There's a common factor. F of x equals x squared, that's the greatest common factor, times x to the first minus 40. Set each of your factors equal to 0. X squared equals 0, together with x minus 40 equals 0. That gives us, let's see, take plus or minus the square root of both sides, we get x equals 3. Here we get x equals 40. So this is a root, and 0 is a root, but that one has multiplicity 2. So it counts twice. Step 3 talks about x-intercepts. We've found them. The x-intercepts are going to be the ordered pair 0, 0 with multiplicity 2 and 40, 0. It's an ordered pair xy with multiplicity 1. We can go to step 4 and we can discuss the behavior. Oh, we're still talking about the behavior, so we're not ready for 4 yet. The behavior at the x-intercepts. Well, if it's an even multiplicity, that means we're going to have a kiss. So 2 is an even number, we're going to have a kiss at 0, 0. And multiplicity 1, 1 is an odd number, so we're going to have a cross at the ordered pair 40, 0. Now let's go to step 4. This is in behavior. Well, let's see. We have a degree of the poly equal to, let's see, the highest power was 3. Okay, so that's an odd degree polynomial. And then the lead coefficient's the number multiplying the highest power of x, that's 1. And that is a positive number. So together, this implies that our in behavior looks like this. When we have an odd degree and a positive lead, this side goes down, this side goes up. So that's what we're expecting. For step 5, we're going to consider the y-intercept, but we don't really need to look for it. Whenever an x-intercept is 0, 0, we know that the y-intercept will be the same. So the y-intercept is 0, 0. Step 6, we'll sketch it. Now, if we need a few points, we'll find them. But let's see, we'll draw the x-axis and the y-axis. Here's the y. And let's make the x pretty high, because most of these things are happening down low. Let's see. We have an x-intercept at 0, 0, so there's a point there. We have another x-intercept at 40, 0, so somewhere over here is the number 40. And we cross here. Okay. Oh, yes, we have a crossing at 40, and we have a kiss at 0, 0. So if we have a kiss and then a crossing, we need to know what's happening to the left and right of 0. So let's find a few points here. Let's take the xy, make an xy table. And let's let x equal negative 1 to see what's happening there. When x is equal to negative 1, y, which we know is equal to x to the third minus 40 x to the second, will be equal to 1 cubed, which is 1 cubed, minus 40 times 1 squared, which is 1. So that's 1 minus 40, that's negative 39. Okay, so that puts this pair, ordered pair, let's say 1's over here, negative 1's here, and let's say that 39 is down here, negative 39. It puts it down here. And if I know this point is down here, and I know that when the graph approaches the intercept at 0, 0, it's going to be a kiss. I know it's coming up from down below. It's going to kiss, turn around, and come back down. Now, I'm not sure how far it's going to come down, but eventually I know it's going to turn around, come back up, and it's going to be a crossing here. This end will have an arrow going up, this end will have an arrow going down. So that is my answer. This is my x-intercept. And I'm finished.